Welcome friends. In the last video we were discussing about the cross multiplication method, right? So again let us go with the cross multiplication method. We are going to solve some of the sums that we have already discussed similar to that of the previous method. I am having one more sum here, that is 5x plus 3y equals to 35 and 2x plus 4y equals to 28, right? So I am having a sum here. I am having a pair of linear equations here, that is 5x plus 3y equals to 35 and 2x plus 4y equals to 28. So now what we are going to do first of all is we are going to convert them in the standard form, right? So we are getting the equations 5x plus 3y minus 35 equals to 0. That is the first equation, and 2x plus 4y minus 28 equal to 0. This is my second equation. So I got both the equations in the standard form. Let us write down the coefficients here. Under x we are going to write down the coefficients of x. Under y we are going to write down the coefficients of y, and the constant terms minus 35 and minus 28. Now to solve them, we are having x upon, that is 3 minus 35, 4 minus 28. The logic goes like, under the variable x we are not going to write down the coefficients of variable x, we are going to write down the coefficients of the y and the constant term, that is equals to variable y. So beside the coefficients of the constant term we are going to write down the constant term, and the remaining column is x, right? That is equals to 1 upon 5, 2, 3 and 4, right? So let us cross multiply this. Therefore x upon minus 28 into 3, that is minus 84, minus minus plus. Okay, so if you don't understand, let me write down minus of minus 140, that is equals to y upon minus 70 minus 140 is equals to 1 upon 5 into 4, 20 minus 3 into 2, 6. See, again let me recall you that we are going to multiply it like this: first term into last term minus second term into third term. Here it is like this: first, second, third and fourth. So first into last minus second into third, right? So let us simplify this again. Therefore that is equals to x upon minus 84 plus 140 is equals to minus 70 plus 140 is equals to 1 upon 14. Simplifying this, we shall get x upon 140 minus 84, that is minus 56 is equals to y upon, this will be 70 is equals to 1 upon 14. So comparing the coefficients, therefore x by 56 equals to 1 by 14 and y by 70 equals to 1 by 14. So we shall get x is equals to 56 upon 14 and y is equals to 70 upon 14, which leads me to x equals to 4 and y equals to 5. Is it clear, friends? So the solution to the given equations here is x equals to 4 and y equals to 5. That is our required solution. You can also confirm the solution by replacing it here in this equation so as to get 35 and 28 in both the equations. Is it clear, everyone? Right? Again we are going to discuss one more sum here, that is I am having one more equation here, that is 8x plus 5y equals to 9 and 3x plus 2y equals to 4. Right, so the very first step here will be converting them to the standard form, that is 8x plus 5y minus 9 equal to 0 and 3x plus 2y minus 4 equal to 0. So that is my first equation. and that is my second equation. Is it clear, everyone? Now again we shall try to solve in the same method that we have already solved here. So again what I am going to do is take out the coefficients of x here. So under the coefficient or under the variable x, I am going to write down the coefficients 8, 3. Under y, I am going to write down 5, 2. And under the constant term, I am going to write down minus 9 and minus 4. Right, so we got these three coefficients here. Therefore, x upon 5 minus 9 2 minus 4 is equal to y upon minus 9 minus 4 8 3 and is equals to the constant term 8 3 5 2. Right, so these are the coefficients written. Now we shall cross multiply them. To cross multiply them, what we need to do is, that is x upon first into last, that is 5 into minus 4 minus 20 minus 9 into 2, that is minus 18, is equals to y upon first into last, that is minus 27 minus 4 into 8, that is minus 32, is equals to 1 upon 8 into 2 16 minus 5 into 3 15. Right, therefore x upon minus 20 plus 18 is equals to y upon minus 27 plus 32 is equal to 1 upon 1. Right, therefore x upon minus 2 is equals to y upon 5 is equals to 1. Therefore comparing it with the constant term, x upon minus 2 is equals to 1 and y upon 5 is equals to 1. Therefore what we shall get, x equals to minus 2 and y equals to 5. So this is our required solution, x equals to minus 2 and y equals to 5. So this is the required solution, x equals to minus 2 and y equals to 5 for the given equations. Right, so in this way you can solve the equations that are given directly to you by using the cross multiplication method. Now let us discuss some of the data type questions also with these questions that can be asked in the question examination. Right, so I'm having a question here that we have already discussed previously also. We are going to discuss the same question, but now we are going to solve it by the cross multiplication method. That is, a fraction becomes (9 upon 11) if 2 is added to both the numerator and denominator. If 3 added to both numerator and denominator, it becomes 5 by 6. Find the fraction. So I am having this question. We have already solved this question in the substitution method, right? We shall discuss the same method by the cross multiplication method now. So first of all we need to form the equations. So according to this question, what we are going to find out, the fraction. So let the numerator of the fraction be x and that the denominator be y. Therefore, the fraction is x upon y, right? So we require this fraction. Once we find out the value of x and y, substitute it here in x upon y, we will get our required fraction. Therefore, according to given conditions, what we are having, the first condition, that is if 2 is added to both numerator and denominator, a fraction becomes 9 upon 11. So we are having the fraction x upon y. If I add 2 to both numerator and denominator, it becomes 9 upon 11, right? And the second one is if 3 is added to both numerator and denominator, it becomes 5 by 6. So first of all, let us solve this. That is 11x plus 22 is equals to 9y plus 18. Taking both the terms on the left side, we will get 11x minus 9y plus 4 is equals to 0. Note that once we find out this equation must be found out in the standard form only, because if you are not finding out this equation in the standard form, then again you are going to convert them in the standard form. So why don't we do it here itself? Let us convert this in the standard form itself, that is 11x minus 9y plus 4 equal to 0. Similarly, we shall get x upon y. Now if 3 is added to both numerator and denominator, it becomes 5 by 6. So again cross multiplying, 6x plus 18 is equals to 5y plus 15. Again taking them on the left side, that is 6x minus 5y plus 3 equal to 0. See, again this equation is also in the standard form. So we got our required equation, 6x minus 5y plus 3 equal to 0 and 11x minus 9y plus 4 equal to 0. Now we shall follow our cross multiplication method, that is finding out the coefficients of x, y and the constant term. So 11 minus 9 4 and 6 minus 5 3, right? So we got the coefficients here. Therefore x upon minus 9 minus 5 4 3 is equals to y upon 4 3 11 6 is equals to 1 upon 11 6 minus 9 minus 4, right? So let us cross multiply them. Therefore x upon minus 9 into 3, that is minus 27, minus 5 into 4, that is minus 20, is equal to y upon 6 into 4 24 minus 3 into 11 33 is equals to 1 upon 11 into minus 4 minus 44 minus 36. Is it clear everyone, friends? So we shall have this. Therefore x upon minus 27 plus 20 is equals to y upon 24 minus 33, that will be minus 7, is equals to 1 upon minus 44 plus 36. So what will be minus 44 plus 36? Minus 8, right? So this is minus 7. Therefore x upon minus 7 equals to y upon minus 7 equals to 1 upon minus 8, right? So what we shall get, x equals to 7 upon 8. So comparing the coefficients, see, I made a mistake here. That is minus 54. So that becomes plus 54, and that is 10. And again, where did I made another mistake? Minus 27. 11 minus 9 4 and 6 minus 5 3. Yes, the equations are good. So let us try to solve it again here. That is x upon minus 7 equals to 1 upon 10, and y upon minus 7 is also equals to 1 upon 10. So I am getting the same values x and y. So the fraction cannot be 1:1 or 1 upon 1, right? Okay, now see friends, we have made some mistake here while subtracting the coefficients, right? So this is now minus 1. So we are getting x upon minus 7 finally as 1 upon minus 1 and y upon minus 9 as 1 upon minus 1. Therefore x equals to minus 7 upon minus 1 and y equals to minus 9 upon minus 1. Hence we get x equals to 7 and y equals to 9. Note that friends, that this x equals to 7 and y equals to 9 is just the solution of these first and second equations. But what do we require? The fraction. Hence the fraction is x upon y, that is equals to 7 upon 9, and which is our required answer, right? That is 7 upon 9 is the required answer. So again, take a look for the solution, friends, that we have made some mistake over here while writing down the coefficients and while subtracting the coefficients. So you might again be aware that we don't make any kind of mistakes here. Is it clear? So the fraction here is 7 upon 9, right? Now again, let us take a look at one more example here. I'm having a question that has already been in the NCERT textbook, right? That is, a part of monthly hostel charges is fixed and the remaining depends on the number of days one has taken food in the mess, right? It is somewhat like this. A part of monthly hostel charges is fixed and the remaining depends on number of days one has taken food in the mess. Right? Student A pays rupees 4 and that student B pays rupees 11804 26 days. Find the fixed charge and that charge of food per day. Right, so we need to find out the fixed charge here and the charge of food per day. Right, we need to find out both of them. So first of all, what we are going to do is we are going to assume both of them as the variables. That is, let the fixed charge be X rupees and that of food per day is rupees Y. Right, note that the fixed charge is X rupees and that of the food charge of food per day, that means this is per day charge, that is rupees Y. Therefore, according to the given conditions, what we are having according to the given conditions, that is student A pays 1000 rupees for 20 days, that means he has took food for 20 days here, and that student B pays 1180 rupees for 26 days, that means student B has taken food for 26 days. Right, therefore we are having the equations like X plus 20Y is equals to 1000 and X plus 26Y equals to 1180. Right, so we got these two equations, but note that if I want to solve it by cross multiplication method, then these are not in the standard form. So first of all, X plus 20Y minus 1000 equals to 0 and X plus 26Y minus 1180 equal to 0. So these are the equations that we got here in the standard form. Let us mark it as 1 and 2. Therefore we get the coefficients here, that is under X we are having 1 and 1, under Y we are having 20 and 26, and under the constant term, that is minus 1000 and minus 1180. Note that, see friends, these two coefficients are too large to multiply, but don't worry about it. It will be easier when you solve the sums, right? Therefore what we are having now is X upon 20 minus 1000 and 26 minus 1180 equals to Y upon minus 1000 minus 1180, 1 and 1 is equals to 1 upon 26. So friends, now you need to cross multiply them. Cross multiplying here means first term into last term minus second term into third term, that is X upon 118 into 2, that is 236. Right, so that is minus 2360 minus 2600 minus 2600, right, is equals to Y upon minus 1000 minus 1180 is equals to 1 upon 26 minus 20. Is it clear? So let us solve them again. X upon minus 2360 plus 2600 equals to y upon minus 1000 plus 1180 equals to 1 upon 6. So 2600 minus 2360, that is again 240, I think, right? So that leads me to x upon 240 equals to y upon 180 equals to 1 upon 6. Therefore x equals to, right, what is x equals to? X upon 240 equals to 1 upon 6, comparing, yes, equals to 1 upon 6. This gives me x equals to 240 upon 6, and hence x is equals to 40. Y equals to 180 upon 6, and this gives me y equals to 30. See friends, we have made again a small mistake of 0 here. Okay, that's it, nothing more, right? So in place of x we are having 400, in place of y we are having 30. So the fixed hostel charge is rupees 400 and the charge of food per day is rupees 30. So the fixed charge, therefore the fixed charge is rupees 400 and charge of food per day is rupees 30, right? So the charge of food per day is rupees 30 and the fixed charge is 400 rupees. Okay, take a look over it. Done? Okay, so that's it about the cross multiplication method particularly, right? You will be having some more questions in the textbook. You can take a look over it and you can solve it by yourself so as to get the practice. Now we shall look at some of the special cases. Special cases in the sense you will be given two equations, and note that friends, one of the coefficients will be missing over there and you will be given a condition, right? The special cases is like this, that you will be given two equations and note that one of the coefficients, either of x, either of y, or the constant term from both the equations or either of the equations, that will be missing, right? You need to find out that missing coefficient, but the condition given to you will be that either the pair of equations are having no solution, either they are having unique solution, or either they are having infinitely many solutions, right? So let us take a look over such examples, whether how to solve them, right? So the first one is 4x plus py plus 8 equal to 0. The second one is kx plus 3y minus k minus 3 is equal to 0, and 12x plus ky minus k equal to 0. And the third question is 2x plus 3y equals to 7 a minus b into x plus a plus b into y equals to 3a plus b minus 2. So you can clearly look over here, friends, that in the first equation we are having a missing coefficient, that is p here. In the second question we are having keys here that are missing in both the equations, and in the third question, look over here, is we are not having the values of a and b over here, right? So in the first question find out p, second find out k, and third find out a and b. But see, if I say that find out the values of p, then it would not be possible for you that what will be the value of p, or what is the condition for being the value of p to be valid, or what is the condition for k to be valid, right? So I say here that find p if the equations have no solution, right? Find p, sorry, not no solution, have unique solution. No solution, it is not possible, right? No solution, it would be clear that if this equation wants to have no solution, then that is not possible. Okay, so the very first thing you are having for the equations to be unique solution is the condition. The condition relatable to the coefficients of the equations. Why, right? We have discussed earlier before starting the algebraic and the graphical methods, I think, or after the graphical method, I think, that is the condition for the equations to be unique, infinitely many, and no solutions. So for unique solution we are having the condition that the solution here is if the equations has unique solution, then the condition being a1 upon a2 is not equal to b1 upon b2, right? So from this equations I can get the values of a1, that is 4, b1, that is p, and c1 8. Similarly a2 is 2, b2 is also 2, and c2 is also 2. Right, so I got these values a1, a2, b1, b2, c1, c2, but we don't require c1 and c2, we just require this much. Therefore, putting the values here, 4 upon 2 is not equals to p upon 2. 2 and 2 can be cancelled, that means p is not equal to 4. Right, note that, friends, the value of p is not equals to 4. What does it mean? That if the given equation wants to have unique solution, then p must not be equals to 4. That means the value of p should never be equals to 4. So the conclusion here is the equations has unique solution for all values of p except 4, right? That means all the values of p, or all the values that you can take here in place of p are valid, but only and only 4 is not valid. Why? If you put p equals to 4 here in this equations, then that equations will become parallel lines. That means the equations will have no solution available to you, right? That means the equation will have no solution, or that means the equation also is also known as parallel lines. So all the values of p are valid except 4, right? So that is the value of p here. Now in the second case we need to find out the values of k, given that find k if the equations have, let me write down it like this, equations have infinitely many solutions, right? If the equations have infinitely many solutions. So if these equations are having infinitely many solutions, then if the Then the condition being a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. Infinitely many solution, that means the condition for coincidental lines or coincident lines, right? So we are having this. Again, let us take out the coefficients here. a1 equals to k, b1 is equal to 3 and c1 is minus of k minus 3. Similarly, we have a2 equals to 12, b2 is equals to k and c2 is equal to minus k, right? So we got these coefficients here, right? Let me make a box over it so that you can clearly look that what the coefficients are. Right, now we are having these coefficients, let us put it over here. Therefore k upon 12 equals to 3 upon k equals to minus of k minus 3 upon k minus k. So first of all I can cut out this minus here and then comparing the fractions here, I shall get k upon 12 is equals to 3 upon k and 3 upon k is equals to k minus 3 upon k, right? So you can also find out like this. You can also compare the first and the last fraction also, so that you can find out the value of k. It does not make any sense whether to compare first, second and second, third. You can also compare first and third. Cross multiplying here, I shall get k square is equals to 12 into 3, 36, and here see you can directly cancel out the fractions also, right? Sorry, not the fractions, you can directly cancel out the denominators also, but rather than cutting down the denominators, let us cross multiply. That is 3k equals to k square minus 3k. So for this we can get k is equals to plus or minus 6, right? K is equals to plus or minus 6, and rather than here we shall get k square minus 6k equals to 0. Therefore k into k minus 6 is also equals to 0. Therefore k equals to 0 or k equals to 6. So note that friends, here we got three values of k. Three values of k. Let us put it here in the equations so that we can get the perfect value of k. So if I put k equals to minus 6, what will be this? Minus 6x plus 3y minus 9 equal to 0 and 12x minus 6y plus 6 equal to 0. See friends, that you can multiply it here, that if I multiply the first equation by minus 2, I can get the coefficients of x and y same as that of the second equation, but not for the constant term. So this is not valid, right? So minus 6 is not valid here. Similarly, if I put 0, then also it won't be valid, because the coefficients of x and the constant term here in the second and the coefficient of y all becomes 0. So that is also not possible. Hence k is equals to 6 is our required answer. You can also check for the common terms here. That means k equals to 6 and k equals to 6 is common in both the solution. Hence the valid value of k is 6. So in this way you can find out the value of k here, right? Now coming to the third question, that we need to find out the values of a and b. Again I am writing down, find a and b given that the equation has infinitely solutions, right? Now see friends, we are going to solve this question slightly in a different way, right? So first of all, let us take out the coefficients. The solution now starts, that is a1 equals to 2, b1 equals to 3 and c1 is minus 7. See, I am converting them in the standard form and then writing the coefficients here. First of all, I am converting in the standard form, so the standard forms becomes minus 7 equal to 0, and that is minus of 3a plus b minus 2 equal to 0. So after converting them in the standard form, I have written this coefficient here, and a2 is a minus b, b2 is a plus b, and c2 is 3a plus b minus 2, but again that will have a minus sign over here, right? So we got the coefficients here, a1, a2, b1, b2 and c1, c2. Now as the question says that as the equations have or has infinitely many solutions, that means the coincidental lines, right? That means the coincidental lines, right? So if the equations are having infinitely many solutions, that means they are known as the coincidental lines, and coincidental lines, that means the same line, right? Coincidental line refers to the same line. That means if you plot these lines on the graph paper, they will show you a single line and both the equations are representing the same line, right? So now what we are going to do here is we are going to directly compare the coefficients of both the equations. Therefore we can say that 2 is equal to a minus b, 3 is equal to a plus b, and minus 7 is equals to minus of 3a plus b minus 2, right? So we got these two equations, a minus b equal to 2 and a plus b is equal to 3. Adding one and 2, what shall we get? If I add 1 and 2, I shall get 2a is equals to 5, and hence a is equal to 5 by 2, right? If I put a equals to 5 by 2 here in 1, substitute a is equals to 5 by 2 in 1, we get, what do we get? 2 is equals to 5 by 2 minus b, therefore b is equals to 5 by 2 minus 2, and hence b is equals to 1 by 2, right? So we got the values of a and b, that is 5 by 2 and 1 by 2. So in this way you can solve the given equations. These are the special cases of finding out the coefficients of the equations that are not given to us, right? But the condition will be given that the equations have unique solution, the equations have infinitely many solution or not, right? So in this way you can solve them. Take a look over it. Okay friends, so let us move on to the last topic of this chapter, that is equations reducible to a pair of linear equation in two variables. Now coming back to the last topic of this chapter, that is equations reducible to a pair of into variables, right? So as the name suggests, equations reducible to a pair of linear equation into variables. Reducible, that means the equation will be converted to a pair of linear equation into variables. But what about before converting them? They might be given or they might not be given in the standard form of a equation equation of pair of linear equation into variables, right? So first of all, let us understand how these equations will be given. Here in this kind of questions, the variables that means x and y are not in the standard form. They will be given in the denominator. That means of the form a upon x plus b upon y plus c is equals to 0. In this way the equations will be given. That means the variables are not present in the numerator directly, right? If it is present in the numerator directly, then they are already the pair of linear equation into variables. But note that they are in the denominator of the form a upon x plus b upon y plus c equals to 0. Now to solve them, we need to assume that let 1 upon x is equals to p and 1 upon y is equal to q, right? We are going to assume that let 1 upon x equals to p and 1 upon y equals to q. Therefore, this standard form becomes ap plus bq plus c is equal to 0, and hence you can say now that this is a linear equation into variables. AP plus BQ plus C is equals to 0. This is a this is a linear equation in two variables now, right? So what we have done is we have simply converted this equation, right? This equation in the form of a pair of linear equation or in the form of a linear equation in two variables, such that we have changed the variables from x and y to p and q, right? The variables are being changed from x and y to p and q. So from this equation we shall get the values of p and q. Substituting here, then we shall get again the values of x and y, and hence which are our required solution, right? So let us try to solve it, or let us take an example and solve it, that how these equations are to be solved here, right? Okay, so I'm having an equation here that is 2 upon x. The first one of this kind, that is 2 upon x plus 3 upon y is equals to 13, and 5 upon x minus 4 upon y is equals to minus 2, right? We are having these two equations here. So first of all, what is the first process? Let 1 upon x is equals to p and 1 upon y is equal to q. So if I substitute this 1 upon x equals to p and 1 upon y equals to q in the given equations, then what shall I get? I shall get, therefore, 2p plus 3q is equals to 13 and 5p minus 4q is equals to minus 2. These are the two equations that I shall get here after substituting 1 upon x equals to p and 1 upon y equals to q in the given equations. Now note that, friends, these 1 and 2 equations 1 and 2 are a pair of linear equation in two variables, right? These are both a pair of linear equation in two variables, and now once I get this pair of linear equation in two variables, I can solve these equations by any of the algebraic methods that we have discussed in the earlier videos or in the earlier sections, right? Therefore, let us use the substitution method here. So from I shall get 4q is equals to 5p minus 2, and hence q is equals to 5p minus 2 upon 4. This is number 3. Right, now substitute 3 in 1. We get 2p plus 3 into 4, right? We shall get this. Therefore 2p plus, multiplying inside, 15p minus 6 upon 4 is equal to 13. Cross multiplying, I shall get 8p plus 15p minus 6, that is equals to 52. Taking that 6 on the other side, I shall get 8p plus 15p. Let us solve it. That will be so I shall get here, that is 23p is equals to 46, and hence p is equals to 2, right? 23p is equals to 46, and hence p is equals to 2. Substitute p is equal to 2 in 3. What do we get here is q is equals to 5 into 2 plus 2 upon 4. 5 into 2 is 10, 10 plus 2 12, 12 by 4, that is 3. So that is q is equals to 3. So note that friends, we got the values p is equals to 2 and q is equals to 3, but we require the solution, and solution means the values of x and y. So again we shall use this condition here. Therefore 1 upon p is equals to x, we have substituted that 1 upon x is equals to p, implies x is equals to 1 upon p, and hence x is equals to 1 upon 2, and 1 upon y is equals to 2, implies y is equals to 2, and hence y is equals to 1 upon 3. So our required solution to the given equations are x equals to 1 upon 2 and y equals to 1 upon 3. Right, so in this way you can solve the equations that are not given in the form of a pair of linear equation in two variables, but they are given as equations which can be reduced to a pair of linear equation in two variables. Right? Okay friends, so let us solve one more of this kind, that is the second one. Two upon root x plus 3 upon root y is equals to 2, and 4 upon root x minus 9 upon root y is equals to minus 1. Right, so friends, now see here that we are not having the variables directly as x and y, but we are having the values of x. That is, in place of x we are having root x, and in place of y we are having root y. So solving them in the same manner, we shall take that let in the same way that we have solved the first one, the previous one, that is, let 1 upon root x equals to p and 1 upon root y is equals to q. Therefore the equations given to you, 2p plus 3q equal to 2 and that is number 2, right? We need to solve them. So in the first one we have used the substitution method. Let us try to solve this by the elimination method. So multiply 1 by 3 and add them. So what shall we get? That is 6p plus 9q is equals to 6 and 4p minus 9q equals to minus 1. Now we shall add them. Adding them, that means no change of sign here. That is 6 plus 4, 10p is equals to 6 minus 1, 5, and hence p is equals to 1 upon 2. Right, so we got the value of p as 1 upon 2. Now substitute. In either of these two equations, so let us substitute it in 1. We get 2 into plus 3q is equal to 2. So this can be cancelled out. So 1 plus 3q equal to 2. Therefore 3q equal to 1 and q is equal to 1 upon 3. So we got the solution to these two equations 1 and 2, that is p is equals to 1 upon 2 and q is equals to 1 upon 3. Therefore what shall we do here is finding out the value of x. 1 upon root x is equals to p. Therefore root x is equals to 1 upon p, that is 1 upon 1 by 2. Therefore root x is equals to 2 and x is equals to 4. So root x equals to 2, that means squaring on both the sides we get root x, square of root x, that is x, and square of 2, that is 4. Similarly 1 upon root y is equal to q implies root y is equals to 1 upon q, that is 1 upon 1 by 3, that is root y is equals to 3 and hence y is equals to 9. So we got the value of y as 9. So the solution of the given equations is x equals to 4 and y equals to 9. Is it clear, friends? So in this way you can solve the sums related to the equations reducible to a pair of linear equations in two variables. Is it clear, everyone, friends? Okay. Now let us solve 2 or 3 of this kind again so that you can clearly come to know that whether how to solve the examples. I am having one more of somewhat different kind here. Right, see, we are given this kind of equations here. 7x minus 2y upon xy is equals to 5 and 8x plus 7y upon xy is equals to 15. Note that, friends, this kind of equations are somewhat twisted. You can say them as twisted, that the equations are not given directly to a reducible method, to a problem of reducible method. So first of all, what we need to do is we need to convert them. Then we can apply the logic that taking x of 1 upon x equals to p and 1 upon y equals to q. Therefore 7x upon xy minus 2y upon xy is equals to 5 and 8x upon xy plus 7y upon xy is equals to 15. Therefore you can cancel out the x here, that is 7 upon y minus 2 upon x is equals to 5 and 8 upon y plus 7 upon x is equals to 15. Note that friends, here we got the two equations 1 and 2 such that they are now in the form of the reducible form. So assuming let 1 upon x is equals to p and 1 upon y is equals to q. Mind well friends that we have taken 1 upon x equals to p and 1 upon y equals to q as per our method, right? So see the first term, it is 7 upon y, so don't write it as 7p, that will be 7q. If you write that as 7p, you will make a mistake while finding out the answer. So that is 7q minus 2p is equals to 5. Let us write down, this is equation number 3, and 8q plus 7p is equals to 15. This is equation number 4. So again let us try to solve it by the elimination method, right? You can also solve it by the cross multiplication method. Okay, let us solve it by cross multiplication method. Therefore x upon 7, 8. See friends, I have made a mistake here while saying to you that first of all what we are going to do, we are converting them in the standard form. So I am not going to give them equation numbers, right? Therefore 7q minus 2p minus 5 equal to 0 and 8q, right, plus 7p minus 15 is equal to 0. So now they are equation number 3 and 4. Therefore q upon, that is 7, 8, 10, we are going to write down the coefficients of p, that is p upon minus 2 minus 15, and the constant terms minus 5, sorry I made a mistake again, minus 2, 7, minus 5 and minus 15. So now what we are going to do, we are going to write it down here in our form, that is q upon minus 2 minus 5, 7 minus 15 is equals to p upon minus 5 minus 15, 7, 8, and is equals to 1 upon 7 minus 2, 8, 7, right? So in this way we are going to write down the coefficients. Now let us try to solve them. Let us try to cross multiply them. So cross multiplying them, what we shall get, q upon minus 2 into minus 15, that is 30, right, minus 35 is equals to p upon minus 40 minus 15 into 7, that is 105, but that will be minus 105 is equals to 1 upon 49 minus 16, right? Hope so that we are not going to make any mistake over here. That is q upon 30 plus 35 is equals to p upon minus 40 plus 105 is equals to 1 upon 49 plus 16. So that is q upon 65 is equals to p upon 65 is equals to 1 upon 65, right? See, the denominators are all same, hence comparing q upon 65 is equals to 1 upon 65, this gives me q is equals to 1, and comparing p upon 65 is equals to 1 upon 65, therefore I shall get p is also equals to 1. So we got the solution to these both equations, that q is equals to 1 and p is equals to 1. But note that we need to find out x and y. So using this relation again here, that 1 upon x is equals to p implies x is equals to 1 upon p, which is 1 upon 1. This implies x is equals to 1, and 1 upon y is equals to q implies y is equals to 1 upon q, that is 1 upon 1, and hence y is also equals to 1. So we got the solution to this given equations, that is x equals to 1 and y equals to 1, right? So that's it about the equations reducible to a pair of linear equation in two variables that are given to you directly, the equations that are given to you directly. I'm having one more sum, but that you are going to do it by yourself. This is somewhat an interesting one, and this can 100% be asked in the examination if I set the paper. Right. So friends, this is the given question to you. Now let me start here up to 2 steps, then do it by yourself. Let 1 upon x plus y equals to p and 1 upon x minus y is equals to q. So this given equations be 10b plus 2q is equals to 4, that is the first one, and 15p minus 5q is equals to minus 2, this is the second one. So using this first and second equations, you are going to solve these equations, get the values of p and q. Once you get the values of p and q, you shall put it here in place of p and q in 1 upon x plus y equals to p and 1 upon x minus y equals to q. Then again you are going to solve it. So in this question, in this specific question, this is an interesting question, like that in this question you are going to solve the equations, or you are going to use the algebraic methods, any of the algebraic methods 2 times. First of all, you will use the algebraic method to find out the values of p and q. Then you are going to use the algebraic method so as to find out the values of x and y, because you are going to get another 2 equations such that they are a pair of linear equation in 2 variables, right? So try to solve it by yourself, and then we shall come up with a solution later on, right? Now we are going on to the last or final stage of this chapter, that is a data type question of this kind, right? Okay, now moving on to the last question of this chapter, that is a data type question of the equations reducible to a pair of linear equation in 2 variables. So the question here to you is, a boat goes 30 km upstream downstream. See, note that friends, this I have written here to save the time, that up arrow means upstream and down arrow means downstream, right, in 10 hours. The second condition, that is in 13 hours it can go 55 km downstream. Determine the speed of the stream and that of the boat in still water, right? So we are having this condition that a boat goes 30 km upstream and 44 km downstream in 10 hours. In 13 hours it can go 40 km upstream and 55 km downstream. Determine the speed of the stream and that of the boat in still water. So first of all, look at this question, friends. We are need to find out the speed of the stream and the speed of the boat in still water, assuming that the water is still when we noted the speed of the boat, right? So coming to the condition here, that assuming that the speed of the boat be x km/h and that of the stream be y km/h. One more thing I would like to add here is, note that friends, the speed of the boat will always be greater than the speed of the stream. Sometimes it might be given in the question, sometimes it might not be given in the question, but you are going to assume that the speed of the boat is always greater than the speed of the stream. Speed of the stream, that means speed of the water in the lake, pond, river, whatever the conditions you take, right? So for example, if we take the speed of the boat as 15 km/h, can you say that the speed of the water will be greater than 15 km/h? Note that if it is greater than 15 km/h, is it possible to live on the earth here? Right, because the speed of the water is too much low as compared to the speed of the boat. So we have already taken the speed of the boat as x km/h and we have taken the speed of the stream as y km/h, right? So we are going to now find out the conditions when the speed of the boat is upstream and the speed of the boat is downstream. Therefore, speed of the boat upstream and speed of the boat downstream. What is the difference here between these two, upstream and downstream? So again, let us understand the condition, the concept behind upstream and downstream. Upstream, that means the boat is going against the flow of the water. That means if the water is flowing from east to west, the boat is going from west to east. That means they are going against the flow of the water. And downstream, that means the boat is going with the flow of the water, right? So while going upstream, the speed of the boat will be x minus y km/h, and the speed of the boat downstream, that will be x plus y km/h. Now you have already know a concept in physics that we are having a relation of speed, that is distance upon time. Speed is equals to distance upon time. So we can say that time is equals to distance upon speed, right? We are not going to use the first one, we are going to use the second one, because here in this question we are having the time reference, that in 10 hours the boat goes so and so, and in 13 hours the boat goes so and so, right? So time taken is 10 hours in total for the first condition and 13 hours in total for the second condition, right? So we are going to make the equations now as time taken to go upstream, that is 30 upon x minus y, and 40 upon x minus y. That is for both the conditions I have written here. See, this 30 upon x minus y, that is time taken to go upstream. That means the distance traveled upstream divided by the speed. Distance traveled upstream is 30 in the first condition and speed is x minus y. That is general. In the second condition it is 40. Similarly, time taken to go downstream, that is 44 upon x plus y and 55 upon x plus y. Again, this is for both the conditions I have written over here, right? Now let us form the equations, that is according to given conditions the first one leads to 30 upon x minus y plus 44 upon x plus y is equals to 10. That is the first condition. And 40 upon x minus y plus 55 upon x plus y is equals to 13. This is the second condition, right? Now again assuming let 1 upon x minus y equals to p and 1 upon x plus y is equals to q. See friends, this is now the equation that I have given you in the homework, that I have solved it here, the fifth one, the previous one. Therefore 30p plus 44q is equals to 10 and 40p plus 55q is equals to 13. This is the third equation and this is the fourth equation. Okay, now let us solve it by which method? Elimination. Let us solve it by elimination. So multiply 3 by 4 and 4 by 3 and eliminate. So we shall get 3 by 4, that means 4 into 3, 120p plus 44 into 4, that is 176q is equals to 40, and that is again 120p, 55 into 3, that is 165q, that is 13 into 3, 39, minus. So this 120p is cancelled. 176 minus 165, that is 5 plus 4, 9. 9q is equals to 1, and hence you get q is equals to 1 upon 9, right? Substitute q is equals to 1 upon 9 in, sorry friends, here we shall not get 9, we shall get 11q. So that is 1 upon 11. So substitute q equals to 1 upon 11 in 3. We get here 30p plus 44 into 1 upon 11 is equals to 10. Therefore 30p plus 4 is equals to 10. 30p is equals to 6, and hence p is equals to 1 upon 5. So we got the values of p and q substituted here in this. So again we are going this 1 upon x minus y equals to p, hence x minus y is equals to 1 upon p, that is 1 upon 1 upon 5. This implies x minus y is equals to 5. That is the fifth equation. Let me write down here below. Therefore x minus y is equals to 5. That is the fifth one. And 1 upon x plus y is equals to q implies x plus y is equals to 1 upon q, that is 1 by 1 upon 11. Therefore x plus y is equals to 11. So that is the sixth equation we got here. Solving fifth equation and sixth equation, we get, if you solve this both equations, you get x equals to 8 and y equals to 3. Therefore speed of the boat in still water is 8 km per hour, and that of the stream is 3 km per hour. Is it clear, friends? So that's it about this question. So again let us take a look that the speed of the boat here is x km per hour and the speed of the stream is y km per hour. We got the equations, conditions, and this is the complete solution to this equation. That's it, friends. So that's it about chapter number 3. If you are having any query, please relate to us or please contact us in the comment section. Thank you.